What is going on, everyone? Nav here, and today we are going to be looking at valid parentheses, and we're going to be going through how we can solve this Leetcode problem. Okay, so let's go through the problem. It says, given a string S containing just the characters, and it gives us all of the possible parentheses values, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, every closed bracket has a corresponding open bracket of the same type. Okay, and then they give us some examples here. So this would be valid, and this one would not. Now, initial thoughts that I'm having is, well, we could maybe split the string in half and then work our way and see if like the left side mirrors the right side. But what we'll realize right away is that won't work because of a situation like this, where any open bracket is like needs a corresponding closed bracket in the same scope. So really, if you really think about this problem and sit down and try to understand what's going on, like in these videos, I want to try to help you understand my thought process, how I'm solving it. So the first thing I'm thinking is like, basically, this is a scope thing. We do this in code all the time. And so how do you track scope? Well, you need to know what the current most opened value is, because that needs to be closed before any other value. Yeah, so this open bracket, the most current open bracket needs to be closed, right? Before any other closed bracket. What I'm trying to say is like, this is an open bracket, this is an open bracket. The second we find a closed bracket, right? That closed bracket must match the most recent open bracket, right? So in this case, we have an open bracket. Oh, here's a closed bracket, and it doesn't match, right? Open bracket, closed bracket matches. Open bracket, closed bracket matches, right? So let's say we had something like this, and something like this, right? Even if we have another one of these, the very first closed bracket we hit must match. This would be the most current open bracket, so these must match. And then now this becomes the most current open bracket, so then the next one must be that. Then this becomes the most current open bracket, so the next one must be that, and then this one, and so on. So you can see the pattern, right? It's very straightforward. We are tracking the most current open bracket, and then when we find a closed bracket, we are checking if they correspond, right? And if they do, we simply pop this one off and move on, right? And what data structure does that remind you of? Well, it makes me think of a stack, right? Because in a stack, right, you got a stack of plates or discs, right? You pop one off, right? You put one on, right? The most current one is always at the top. So pretty straightforward problem here when you think about it like that. Now, a couple constraints that I would clarify, and I know Leetcode does it for us, but a couple questions I would ask if someone asked me this question is an empty string considered valid? And what is our length, minimum length and maximum length? In this case, they tell us it's between 1 and 10 to the 4. So I would argue that, well, there can't be an empty string, but we know for a fact that straight up, if s.length, we can skip the whole operation and save us some speed, right? If s.length is equal to 1, we don't even need to like do anything. We can literally just return false. We know it's false. The next thing we need is a left param stack, right? And typically we'll use a list or an array to denote a stack because it gives us the ability to pop and push very easily on the end. So if you kind of think of an array like this, right, with like 1, 2, 3, 4. Think of it actually mentally like this. With 1, 2, 3, 4, this would be like the stack representation of our array. And so in this case, we need a left param stack. The next thing we need is a way of knowing that the first closing bracket is the correct closing bracket for the topmost item on the stack. So we need some sort of param mapping, right? And this mapping is a little bit tricky to wrap our head around, but I'll try to do my best to explain it. So we're going to map every closed bracket to its corresponding open bracket. Okay. So in this case, there's only 3 scenarios. So we'll use the closing bracket and the open bracket, right? And same thing here. So we'll use the closing bracket, the squiggly one, and that's the open one. Whoops. Yeah, and just make sure it's your 3 closing brackets there being mapped. Okay. So pretty straightforward. As soon as we hit here, we want to check if it's the topmost item in our stack, right? So now we can move into our for loop. So we're gonna this is JavaScript, so we'll just, run a basic I is less than s.length, and then I++. Now I could do this with the for each method, but I want to keep this as pure as possible in terms of like raw code, not using method. I mean, it doesn't really matter. I could have actually, this is string, so this is probably the best way to do it. Just any for loop here, it doesn't matter. If you're looking for code syntax, we can clean it up after. But anyway, in this case, basically I need to say if, and how do we know we're at a closing bracket or an open bracket? Well, we can just do a basic lookup, right? If s at I, right, is not, if not param mapping s at I, meaning if none of these keys match, right, param mapping. Now another constraining question to ask is like, can I get any noise, like are we going to get any values in the string that are not brackets, right? Because then we have to add, if that's the case, we would need another check here, which is like if, like is param, and then I would add a little helper method to check that. But in this case, I think it's safe to assume that we're only going to get brackets, but I would always clarify that. That's a question I would ask at this stage. I'd be like, hey, can we only get brackets? Because, and then if we don't only get brackets, like let's say we get other letters, am I just to ignore those other letters, or do those other letters matter in some way? Anyway, okay. So if it's not in there, it means that we need to push it to the stack, right? Because these are our closing brackets that are in there. So we need to say left param stack dot push, and we need to push s at I, right? Because we have an opening bracket, right? Otherwise, we need to check. So we'll just say let current open param equal left param stack dot pop, right? We're just going to simply pop the item off the top, and then if current open param doesn't equal the param mapping at s at I, meaning, so we popped an opening, we pop an opening bracket, right? So we're at a closing bracket. We pop the most recent opening bracket. We check if that doesn't equal the mapping. So in other words, we're hitting this case, right? If this is true. And then we return false, right? Otherwise, we just continue because we pop the item off, which will remove it from the stack, right? And in this case, we're done. There's just one last check we need, which is at the end. We can't simply just return true, because what if we hit the case where there's only like there's still items left in the stack? So like, what if we had a scenario like open, 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 open. I don't know why. Like a scenario like this, right? A scenario like this, you would still have items on your stack, so therefore it's not valid. So we need to just say like if left param stack dot length is greater than 0, then we return false, right? And I could probably do this in a ternary, but I think just to help you guys understand, I'll just do it like this. And that's it. And so if I hit submit, I'm pretty confident in my answer here. I think I've covered all the cases. Turns out I do. And you don't have to worry too much about the runtime. I don't think it matters too much in terms of like Leetcode, but this seems to be a pretty good solution. You can analyze the complexity, and we'll get ON, which is good. we solved this problem. So if you found this helpful, make sure you like the video, subscribe for more awesome videos, leave a comment below, and let me know which problem you want me to try to work through next time. And I'll see you then. Goodbye.